in person starting March 1st, which as a teacher, it's really good to have more students in the class. Today, even my Thursday, Friday group is definitely nice and large. Just makes it feel more like it's supposed to be, more like school. So just a little reminder, there is an email that went out last night at like 7:45. Please have parent guardian fill out that little 3-question Google form about what you will be doing so that I have an idea as to who's coming. I might even send my own Google form and have you fill that out as well. But it is either a 4-day option, you go Monday, Tuesday, Thursday, Friday, still Wednesday is total virtual, or you would remain at home, but continue to join synchronously, which means continue to join in the live lessons 5 days a week. From now on, if you're absent, meaning you're not in school, you're not joining online at home, you have to submit an excuse, a written excuse. So that is a little new and more like school was before. So make sure you have somebody at home check your email, check their email, and they complete the Google form from Dr. Marino. So we are going to go over a couple of questions today from the review worksheet. I also have a few things that I just want to reinforce with you that I've noticed over, I'd say like the last week and a half with homework, just some misconceptions and mistakes that I've been seeing that I want to make sure it doesn't happen. You do have a Chapter 6 test on Monday. That Chapter 6 test is 3 pages or 3 slides. So I'm not exactly sure how many questions it is, but 60 points, 3 slides in notability. So I think the review worksheet has 4 pages maybe. I think it might be 4. So it's 1 less, obviously fewer questions. So we would have 2 questions about graphing and 2 questions about inverse functions instead of 6 kind of thing. So that'll be a test on Monday pretty much right away. The only homework you would have on Monday is to make sure you upload your notes. Otherwise, there is no homework on Monday besides uploading the notes that we've taken for Chapter 6. So we're going to go right into the review worksheet. You want to pull out your review worksheet. Going to look at 9, 10, and number 19. And then, as I said, there's a few things that I just want to kind of discuss with you, dealing with the graphing, dealing with inverse functions. I think the solving equations is pretty good, but just kind of go over a few things before I let you work on this. Number 9 is a multiplication of 2 functions. So this operation is called a combination. We're combining 2 functions together. The 2 functions are a little more interesting than just a basic line. So we have an exponent in these functions, and the first function f is 2x squared, 3x to the half minus 5. Remember, once you have more than one term, a term is separated by an addition or subtraction sign. It's a group. You want to group that together in a quantity. We are multiplying that with x minus 4x to the 1/2 and then plus 1. Now, the process of multiplication, FOIL is used when you have 2 terms times 2 terms. That's FOILing, because each one represents first, outer, inner, last, the 4 ways to combine the terms together. This is more using the distributive property. You're going to distribute each term in the front to everything in the back. And we did these problems in Chapter 5, but Chapter 5, we didn't have fractional exponents. So that would be the difference between Chapter 5 and 6. When you use the distributive property, when you're multiplying, you have to add the exponents. So 2x squared times x makes 2x cubed. And then this one's a little trickier. We're taking 2x squared times negative 4x to the 1/2. If I multiply my numbers, I get negative 8. But you have to add the exponents. So you're taking a 2 and adding it to a 1/2. So you're adding the exponents. Well, 2 is really 4 over 2. And if I add that to a 1/2, I end up with x to the 5/2. So multiplying means adding your exponents. The last one's easy because it's just times 1. So plus 2x squared. So that would be my first term multiplied together. And then you're going to do the second term, taking it all the way through. So Ella, if I multiply 3x to the 1/2 to that back trinomial, what do you end up getting there?
3x and 3.
So being careful with those exponents, excellent job. X to the 1/2 times x. Well, that x is really a 1 or a 2 over 2. So 2 over 2.5 make 3 over 2. 3x to the 1/2 times negative 4x to the 1/2. You get negative 12, and then a half and a half make a whole. That's why you just have an x here. And then that 3x to the 1/2. So one more time, you got to distribute the last negative 5. And thankfully, it's just a negative 5. So all of the x's in the next one just get multiplied with negative 5. So we have a negative 5x, a positive 20x to the 1/2, and then a negative 5. So you have 9 terms because you're taking 3 things and multiplying it by 3 more things. 3 things times 3 things make 9. That's why you have 9 terms. Questions on that step? It's pretty, just make sure you're like taking it piece by piece. So there's a lot to look at here, Jaden. Is there any terms, or are there any terms that we can pair together?
Yeah, so you can put together the negative 12x and the negative 5x and make it negative 17x.
Okay.
And then the 3x to the 1/2 to 1/2 plus 20x to 1/2.
So 20 and 3, you said, right?
Yes.
Okay. And you said that made?
23x to the 1/2.
Yeah. And then we have a minus 5. And then all of the stuff in the front here, all of that, different exponents, so they're different terms. So we would just write that as well. So we have a 2x cubed, an 8x to the 5/2, 2x squared, and then 3x to the 3/2. I have my exponents in descending order. So the largest power is first, and then they descend in order. Questions? So a good problem because it applies multiplying from chapter 5, but also exponents from chapter 6. Questions on that? Number 10, one question at home, sorry.
Yeah, wouldn't 3x to 3 over 2 be before 2x squared? Because isn't that like
So
2.5?
3/2 is what? 3/2 is 1.5. 5/2 is 2. It's okay. No
I don't
worries.
know. I couldn't get that through my head.
It's okay. It's a Friday morning. Any other questions? Good. So number 10 was another one that I saw on the list. So just give myself a little room for this over here. Number 10 is division. You're taking f of x and dividing it by g of x. So my f of x function goes on the top. The g of x function goes on the bottom. Can you divide each one of those terms by the same number or by a variable with the same exponent? Meaning, do all of them have the same GCF in common? No. So with a fraction, don't get cancel happy. These guys can't cancel just because they have a power of 1/2. In a fraction, what you do to one, you have to do to everything. It's almost like an equation. What you do to one side of the equation, you have to do the other. So there are 6 terms up here in this fraction. If you do something to the first term, you have to do it to all of the other terms, all the other 5. So if they all were divisible by 2, then I could divide them all by 2. But we have a 3 and a 5 and a 1, and they aren't divisible by 2. You can't divide out the x's because, yes, you can take it out of the middle, but you can't take an x to the 1/2 when there isn't an x with the -5 and the +1. So fractions actually do not simplify as often as students think they should. So don't force something to cancel from it. Jaden.
How come you can't divide the 1 out of there to like cancel it out? Like, is it because it's added to that other quantity? Okay,
Yes.
that's what I thought.
Yep, that is exactly why. Any other questions? Okay, so I'd like to go over one more that I had questions from the worksheet, and that's number 19, which I said yesterday I would be going over anyway. And then I wanted to just kind of talk about inverse functions, and I wanted to talk about graphing and correct values to choose when you're graphing, not just picking random numbers, but picking numbers for a specific reason. So looking at 19 first, this one, the directions say to find the inverse function. So if you're finding an inverse function, Ava, what's the first step when you find an inverse function?
You switch the x and y.
Yeah, so this is really y equals. Take your function, switch x and y. So now I have 2 y's. 4 minus y over 3y. And then Ava, what is the goal after you switch the x and the y? What's the next step?
To get 1 minus.
Yeah, we're going to try and get y by itself. Now, right now, it has divided by 3y. And on the top is a 4 minus y. So again, I cannot just cancel the y's out because the 4 doesn't contain a y. So we have to try and get y by itself. And the first thing we need to do is take this out of fraction form. Right now it's a fraction. So let's get it into a more linear format where everything is lined up horizontally. And to do that, you can multiply 3y to the other side so that it's no longer in the denominator. That's how you take something out of a denominator, by multiplying it. Dividing is really also multiplying by the reciprocal. So if I'm dividing by 3y, if I multiply by 3y, take it to the other side, then I no longer have a fraction. So we have 4 minus y. And on the left, I have 3 times y times x. I'm just going to write that with the x first. So the goal is to get y by itself. Right now, you have a y on the left side and a y on the right side. If you want to get y by itself, you need to have y on the same side of the equation, because I need to be able to get those y's together if I have to get y by itself. So Ella, how can I get the y's on the same side of the equation? Yeah, just add y to the other side so that it's only equal to 4. So 3xy plus y equals 4. So y's are on one side, also with x, and a 4 is on the right, but the y's are together. So now you have to use your math skills and everything that we've discussed this year, because math is cumulative. You learn it, you use it. We somehow need to get y by itself. And there is a way that you can get y by itself. Does anybody have an idea as how you can get y by itself? It's going to take 2 steps, but I have to do one thing first. Ella, do you know? It's like, no, I don't. I really didn't want you to call on me. Anybody at home have an idea how you could get y by itself? Right now, y is with 3x, and then I have a plus y. That y really has a 1 in front. What do both those terms have in common? So this has a 3xy, and that's a 1y.
Why?
They both have a y in common, yeah. And when two terms have something in common, that's called the greatest common factor. And you can factor out what they have in common. We're not dividing, but we're factoring it out. So I'm pulling out the GCF and writing it in front because they both have a variable in common. If I pull it out, that means I have a 3x and a 1 remaining inside. Factoring is a way to pull something out that two terms have in common, greatest common factoring. And then it's equal to 4. So to get y by itself, you are multiplying it right now by a quantity because I factored out the y. I now have a quantity it's being multiplied by. If you divide by that quantity, the whole quantity, those two terms cancel, and y is by itself. So I'm going to write it in inverse notation because my terms next to the y cancel. And we end up having 4 and then 3x plus 1. That's a great honors level question. That's why you're in this class, to challenge yourself. Some of you are probably thinking, I'm not really sure about that. Alyssa.
Can you go over number 18?
Of course. Any questions on 19? Number 18 is a great question to go over because it actually kind of goes into something that I wanted to reference. Number 18, we have f of x equals 4x squared plus 1. But then next to it, it says x squared is greater than or equal to 0. If I didn't have this x squared is greater than or equal to 0, does anybody know what shape of graph 4x squared plus 1 looks like? So what's the shape of the graph, Jaden? You're so close. What's the other letter?
Oh, parabola?
Yes, it's a parabola. So this graph is a parabola. We said in section 6.4 that not every function has an inverse. Does anybody know why a function would have an inverse versus would not have an inverse? There was a test that we did in section 6.4. So we looked at the graph and then we did a test with the graph. What was that test that we did? Ava? It couldn't cross? Not vertically, the other way. Horizontally. Yeah, it's the horizontal line test. So if you draw a horizontal line and it crosses through the graph more than once, we would say that the inverse, this is a thick pen right now, is not a function. So not all functions have inverses. You actually need to look at the graph and see, would the graph make an inverse function? And this one would not if that x is greater than or equal to 0 was not in the problem. But this problem says x is greater than or equal to 0, which means that I have the x side where the values are bigger than 0. I have half the graph and not all of the graph. Then it has an inverse because it would pass the horizontal line test. To find the inverse, I do the same process. So I'm going to switch x and y. Oops, that was supposed to be a y. And then you have to solve for x. So this, I'm sorry, solve for y. So to solve for y here, I would take the 1 to the other side, divide it all by 4. You can keep that together, you can separate it. It's up to you. And then to get y squared by itself, we need to take the square root of both sides. But you're taking the square root of everything. So you're taking the square root of both pieces here, that whole fraction, not individually, because that fraction is combined together. So I would have y equals the square root of x minus 1 over 4. Questions? So when you're taking a square root and there's a quantity, you don't individually square root things. Again, a quantity is held together, so keep it together. Jaden.
I just don't like when the answer key is not, it's squared individually on there.
So the answer key is because if I have a square root, one of the properties of a square root when you're dividing, you can, no, it's okay, take the square root of the top and you can take the square root of the bottom. Can you take the square root of the bottom in this case, Jaden?
Yeah.
You can get 2. But that doesn't happen all the time because if there was a 3 down there, I can't take the square root of 3. But I still keep that x minus 1 underneath its own square root. Questions? Good question to ask, Alyssa. So the other thing that I wanted to talk about that I know a lot of students seem to be a little unsure with, if the directions say verify, there's a difference between finding an inverse and verifying if two functions are inverses. So if I look at number 14, Jaden, what was the inverse function that you found for number 14? Okay, thank you. So in number 14, the original function is 3 minus 2x. Its inverse is negative x plus 3 divided by 2. If you're asked to verify, and that's the key word, that two functions are inverses, to verify, you need to show f of g of x equals x, and g of f of x equals x. There's a difference in the way the question is worded. Finding an inverse is just finding the inverse. Right here, that's finding the inverse. Number 18 and number 19 is finding the inverse. Verifying means they're giving you two equations. We want to show that they are inverses of each other. And to do that, you need to take the one function and plug it into the other. So I would have 3 minus 2 times, and then my x is this function right here, negative x plus 3 over 2. To verify, my terms should cancel. So I can see that my negative 2's cancel because multiplying and dividing make them cancel. And then I still have a negative left and that numerator quantity. So that would become 3 plus x minus 3. Verifying means they should simplify to be x if they're inverses. There aren't any questions on the review like that. That's something you'll probably want to look over because I know a lot of students, that question was on the 6-5 worksheet, the last two questions, still aren't answering that correctly. If you do not do the verifying process, so that's half of it, you need to do the other way as well. And you just find the inverse, you really didn't answer the question. And if it's a 5-point question, maybe I'll give you a point, but verifying is showing that f of g of x is equal to x and g of f of x is equal to x. And that's section 6-5. I'm sorry, 6-4. So please remind yourself to look over that. Questions? All right, so the last two things that I just want to talk about is a little graphing here. So if you look at number 20, let's do 21. It says graph the function, state the domain and the range. This is a square root function. So when we have a square root function, you need 3 points. Make yourself a little t-chart. Yes, you must make a t-chart. The first number that goes in the t-chart would be the h and the k value. So this is y x minus h plus k. So the first number in my t-chart is going to be a -2 and a +2. The 2 underneath the square root does not add with the 2 outside the square root. They're different types of numbers. One is a radical, the other one is a whole number. So it would start at -2 and 2 because underneath it's supposed to be x minus. Well, a +2 is really a minus -2. And then you need to pick 2 more numbers. And the numbers you choose need to make this square root be a perfect square. So don't just pick a -1 or a 0 or a 3 or a 4. Think about it. So I want to choose a number that underneath the square root, I get a perfect square. So a perfect square would mean making it equal to 1 or making it equal to 4. So what number could you choose underneath the square root so that some number x plus 2 equals 1? Gabby Soul, what number plus 2 equals 1? -1. And then you're plugging -1 into the equation for x. And if you need to show a little side work, that's fine. But you are taking the square root of -1, plus 2, and then outside is also the plus 2. So the square root of 1 is 1, but now it's negative. So now I have -1 plus 2 makes 1. The next one, I need to choose a value to make 4. So Gabby Soul, what number plus 2 makes 4? 2. So I have 2 plus 2 and then plus 2. So the square root of 4 is 2, but it's negative. And then -2 plus 2 makes 0. These x values that you're choosing should not give you a decimal. It should give you an exact number. There's no reason you should use a calculator because you should be choosing values that make perfect squares. So now that I have -2, 2, that's my first point. -1, 1, and 2, 0. When it's a square root, it's half of the graph. So it starts at your critical point and then hooks. Make sure it hooks to the right. It doesn't hook downward or it doesn't hook upward. It hooks to the right. So it shouldn't be going down. It shouldn't be going up. It's hooking to one side because it's a square root graph. I can't have negatives underneath the square root. The domain starts wherever x starts. Well, my x was -2. The range, well, this graph is going down eventually. So it's going to go from -infinity, since it's going down, up to that +2 value. So use the graph to help you with the domain and the range. Where is it going? What's the behavior of the graph? That's what that's called. And then the last one, let's look at, why don't we just do number 23 right underneath? Number 23 is a cube root graph. So that means it has both sides. It has the x and the y. So it has both sides, stretching left on the x, right on the x. Cody, do you know what the critical point is in number 23 from the equation? Anybody know what the critical point is for number 23? Abby? Yeah, 3, 4. That goes in the middle. So your critical point, when it's cube root, it's the middle of the graph. And then I need to pick 2 numbers that make it a -8 and a -1. That would be to the left. And 2 numbers that make it a +1 and a +8. The reason we're choosing these is because you can take the cube root of those numbers. So you need to plug in a number that makes it a -8. Well, we have x minus 3, -5 minus 3 makes a -8. And then I want to make it a -1. So if I plug in a 2, 2 minus 3 makes a -1. The next number I want to make is a +1. Well, 4 minus 3 makes a +1. And then finally, I want to make a +8. 11 minus 3 makes a +8. So those will be the x values that you want to choose. Because when I plug them into the equation, they make a perfect cube. So I'm going to stop talking and let you work for the next 10 minutes. Does anybody have questions? The last group of problems on this review worksheet are all equations. Make sure you're checking the solutions on the answer key. Don't forget that if you take a square root, your answer is plus or minus, or a cube root, your answer is plus or minus. If you have questions, email me or join me at 7 o'clock on Monday, and I will open up the Zoom early. And if you want to join early, I can answer any questions that you have. If you're in school on Monday, because you're in Group A, please ask during that time in homeroom and before school when you get here. Ask any questions that you have. Does anybody at home have questions to ask? You can feel free to remain on if you're at home, or you are welcome to go continue working on this for the next 8 or 9 minutes that are remaining in class. Have a good weekend, everybody at home. I have 23 graphed up here with the y values. Again, make sure that it's going left and right. So it shouldn't go up and down. That's a different graph. It should curve, arch to the left, arch to the right.